Hello, our YouTube viewers. I'm Albert once again, Albert Mambondian from Zimbabwe. So today I'm going to present a system done in Python. Alright, so I'm going to show you how I set up the tools. So, right, so I used Anaconda Navigator, right, and also Anaconda Jupyter Notebook as the IDE for the system. Right, so I'm just going to run through how I installed the project and how to run it, so that when you have the source code, possibly you can run it on your own. Right, so this system basically is about C-section classification. What is the probability that a certain woman, a certain girl, can go through C-section during her next childbirth, or rather during the next time on giving birth? Right, so we need to at least have a certain prediction of the probability that a person could deliver a baby through C-section or through the normal birth. Right, so we have a various set of information that we collect from the person, so that we can at least have a sense of direction, so that we can at least make a report that at least maybe, for example, 50% of women who had a C-section birth were under the age of 17, something like that. So we just need that classification, that at least we can have those classes and those reports, that what really that do the current statistics looks like. What is the possibility of a woman to give birth through C-section? Right, so here we are using Anaconda Navigator to just set up the tools. So please kindly follow what I'm doing here if you need to run the same project on your computer. Right, and also I am going to provide the data set. Possibly you need it to present in your school project. I'm going to provide the data set as well. Alright, so here we just need to set up an environment, and here we are not using the default root. Right, we are going to create a separate environment and label it as TensorFlow. So right, so here we have labeled it as TensorFlow, but rather TensorFlow is not a pre-installed thing. We just had to create it and manually name it TensorFlow. Okay, right, so after we have manually named it TensorFlow, we need to install certain libraries that are necessary for our project. For example, the basic ones, we have Panda, we have NumPy. Those are the very much obvious libraries whenever we are doing Python. Alright, those are the very necessary projects. So my computer may be a bit slow, but I'm sure when you try to write it on your own machine, I think it will give a better performance. So I'm just going to wait for it so that I can load my TensorFlow library. So this is not the root that is currently loading, because I've pressed base root by mistake. I need to press TensorFlow so that I can enter into TensorFlow. Alright, so that at least if I enter into TensorFlow, I can run it and then select Jupyter Notebook from the TensorFlow environment. Alright, so I'm just going to write to run Jupyter Notebook to launch Jupyter Notebook from here. It's going to make my life a little bit easier. So I don't know where you are going to watch these videos from. I'm going to upload as many videos as I can to at least provide an idea, or at least a clarification, or at least an idea of who Albert Mambondian is. Alright, I'm just a freelance software developer. If you want to hire a software developer, possibly part-time or full-time, I'm here for you. Okay, I'm here for you wherever you are. And also if you need part-time assistance, I can just assist you by you just need to pay a small deposit amount, and then alright. So our source code is divided into various sections. As you can see here, we just need to run an online image or an image in my computer, an image of a pregnant woman. Alright, that's not a very big deal. Alright, so here we have a data set. Alright, it has different categories that we need so that at least we can make an analysis of the prediction. For example, we need the age of the person, how many times has the person given birth, when she has previously given birth, were they prematures, were they latecomers, and were they on timely deliveries, and also what is the current blood pressure for the person. Is it low, normal, or is it high? Does the person have heart problems, and so forth. These are the only and major values that we are going to analyze. So in the data set that we have, there are only ones and zeros and twos in the data set, right? The data set can have true, false. As the person has a heart problem, it says that a yes or no. But in this, for the sake of processing, we are just going to use ones and zeros, right? Once the person has had a heart problem before, and zeros, the person has not had a heart problem before. Alright, so that's I think that's quite clear. Alright, so for example, delivery time, how soon or how early does the person previously has she previously given birth? Were they early deliveries? Were they on time, or were they latecomers? How many did she had before? Okay, so now we need to just get just a small information from the data set, right? We just need a head of this data set, so just going to print for us 5 rows. Alright, so here we have 0, 1, 2, 3, 4, but there are actually 5 rows. Okay, so this is just the head of the data set. In other words, this is just a glimpse of the data set. Okay, so as you can see, the data set is locally available on my computer. I can send it to anyone who needs it. And also, as you can see, the last part of the data set, it has a conclusion. So this is the data set in my computer. Alright, this is the Excel file. The Excel files, we have the various attributes and their values. So the very much important thing on this data set is the outcome. We need the outcome one way or the other. Has the person had a C-section birth or not? Alright, so the person, so the zeros, these are the people that did not have a C-section birth, and the ones, these are the people that actually had a C-section birth, right, that delivered through a C-section. Okay, so we are saying we need to collect, has the person given birth before, how old was she, and then at the end of the day we need to say yes or no. Did they had a C-section birth? No, that's a 0. Did they actually had a C-section birth? And then that's a 1 if it's a yes. Okay, I think that's quite clear. So this will help us to categorize our clients if they fall under certain similarities of certain individuals that we have in our system, that at least would derive or predict that the person will deliver through C-section. Then it implies that the client may deliver through C-section as well. Okay, that's not really a certainty, but at least it's a percentage of analysis that at least this person with his characteristics would deliver in a certain way. Alright, so here we have about 80 rows in this data set. Alright, let's scroll down. They're adding up to 97, subtracting the rows on top, it adds up to 80 lines. Okay, So script rows 17, we have 17 rows that do not have anything usually on top of the data. Alright, so in this data set we need to at least scan for duplicates values. For example, we at least we have values that may have the same age, the same delivery number, the same delivery time, the same blood pressure values, the same heart problem values, and the same outcome for whether the person had a C-section birth or not. So these are the duplicates values we are scanning in the data set. We need at least to see how many of them that we have. There are at least duplicates, because we need at least to randomize, to take values from different people, so that at least we can have a better classification of our model, right? So in this case we have about 4 duplicates. 76 plus 4, that's 80. So we have about 4 duplicates in the system, but we need to remove them, so that at least the dataset will not be filled with duplicate values. Alright, so as you can see, these are the duplicate values. You can see we have duplicate values where the age is 32, and these are the values of that person, and it's duplicated true. And also for the person of 19 years of age, and star in the details, 29 and the details, 28 and the details, what was the blood pressure, was the person had the problem, the person had a heart problem issue, was this value duplicated? Yes. So these values were duplicated with another row in this system. So we just need to go in the system, just delete this row number 47, this row number 61, this row number 71, and this row number 72, just to delete them. Or we can use just a code to delete these 4 rows of data. Alright, so whatever a way will be flexible for us would do, so that at least we don't have duplicated values. Duplicated values, they are quite a danger for us, because they give us wrong statistics. We need to give correct charts of what really happens in real life. Alright, so that at least if you can give a prediction to a person, it will be a true and not manipulated with duplicated values. Alright, so as you can see, now we are now printing another section of the source code. We need to duplicate these values, these 4 values, and also determine whether the condition or whether the outcome was also duplicated. For example, we have a client with 32 years of age. Of course, they are the similar values as the ones in the dataset, and another patient's details were exactly the same, but these people, 2 people had C-section. Yes, they had the same outcome. And then yes, for this 26-year-aged person, they had the same outcomes, and so on. Alright, so we just need to clarify that these people really had the same outcome. Alright, when they were giving birth, they had the same outcome. So duplicated condition is true. Alright, so don't know where you are going to watch this from. Here in Zimbabwe, we are available for you 24/7. Don't worry about the time thing. Just send us a WhatsApp message if you're interested in any one of our systems, a similar system or a completely different system. I don't know if you're a school, a church, a student, an organization, a small company, a big company. We can do it for you, so long you are here, so long you are open to us about your requirements. We can do them for you. Alright, so since so many people had issues with trust issues with their international source code and international assist technicians, right, developers. Alright, we can develop it for you for free. Send you a video of how your system looks, and then if you are interested with it, then you can pay for it. But if you are not, you can ask us to change this few, and then we just keep on upgrading the system till you are satisfied that at least I am now satisfied. Then you can pay your amount, then we can send you your zipped folder of your system, or even upload it for you, whatever is flexible for you. All right, so here is just collecting a few information about our system, right? So by describing the data set, we just need to we're just concerned about a few values. What is the minimum? What is the average age? All right, what is the average delivery number? All right, so most people in this data set at least one delivery, one prior delivery. That means they've delivered at least once. And also on average 57% of the women in this data set had a C-section birth. All right, so we have standard deviation, minimum, mean 25% at 50%. So whatever value that you need to use is the one that you can actually concentrate on. All right, so now we need to do the all right, so as you can see, now we are now dividing the value of C-section with 80. all right, so if you are saying all those ones that we have for C-section birth, how many were them? Then we say they were 50, and then divide by 80, and then they give us a certain value. So right, so all those people with ones there are 50, they constitute 57%, and then all those who did not deliver through C-section were 42%. all right, so this is according to this data set. There could be a different data set that gives potentially different results. That's acceptable, you know, depending on the country, possibly depending on the race and stuff. We don't know. All right, so here in this in this system there is a library called Seaborn and the one that is called Matplotlib. There are requirements for the system, so all you need to do is to just install them. You can install them whilst the system is running. You can just open a new tab or go to home, whatever it's flexible for you. Then just go to CMD command prompt. That is the one that is flexible for me. Install the libraries, and then you are good to go. All right, so now we need to make an export of the values of what our dataset really looks like, right? Using graphs and using charts, using line graphs, using whatsoever that we can to at least try to elaborate as much as we can what really is going on. All right, if you already have the libraries installed, then we are just going to, you're not going to get any errors here. But if you don't have the libraries installed, you're definitely going to get an error, right, when running this part of the source code. All right, so now we need to export all this, just this little simple source code into a graphical presentation of our data set. All right, what do we really mean with each category of value? What do we really mean by any chance of giving a C-section childbirth, right? So this, for example, the first chart, we are saying how is age affecting a C-section delivery method, right? So as you can see, the age on x-axis or on the horizontal axis, the people between the age of 25 and 27 are the highest in terms of delivering through C-section. And then on the delivery number, the people who are the first timers have a very high chance of delivering through C-section. As you can see, the person who is now on the fourth, who is now giving birth for the fourth time, has a lower chance of delivering through C-section than a person giving birth for the first time or for the person delivering for the second time. All right, so as you can see, people with Alright, now going to another section of the data set. We need to to at least have an idea how delivery time affects delivering through C-section. Alright, so let us scroll down. Alright, so delivery time here we have 0, 1 and 2. So these values, they differ. So 0 was presenting people who have delivered on a normal time, and 1 was representing people who have done a premature birth, and then 2 people who have done a late comer type of birth. I don't really understand what they mean by late comer, premature, but possibly if you are in the medical section you can have a better understanding. Late comer, I think I don't know how they classify a late comer, but according to this data set we just have late comers, prematures, and then normal deliveries. Alright, if your blood pressure is normal, you have according to this data set, people with a normal blood pressure had the highest chance of delivering through C-section. Possibly it's because most women have a good high blood pressure whenever they're giving birth. So people with a heart problem, people with actually heart problems, they have a lower risk of doing C-section. This is possibly because very few women actually do have the heart problem. Okay, all right, so this is now the final chart of that is just showing how many people actually had the C-section and then how many people actually didn't have the C-section. All right, in terms of graphical presentations. All right, so now we are now joining two values from the data set: age and number of prior deliveries. How many times has the person given birth before? Alright, so the delivery number is on the vertical and then the age is on the horizontal axis. Alright, so as you can see, according to color, whenever the color becomes darker, it shows where most number of people lays. Alright, so as you can see, between the age of 24 and 25 we have a very large number of people who have given birth once, and then between the age of 26 and 28 most people have most women have delivered for the second time, and so forth. All right, so the darker the color, the more number of where people lay. All right, for example, we can see that a very few number of people, women between the age of 34 and 36 have two babies. That's just the statistics of what we have. All right, so most people, however, they lay between their first number of delivery. At least they are just, most people in this data set are giving birth for the first time, even up to 40 years. It's quite, there's something there, there's something there. All right, so now moving on. As you can see, this graph, delivery numbers and age with vertical bars and actually horizontal bars. So these hexagon squares, they just present where most number of people lay. Right, where there's most number of people. Okay, so in this case we are shown through these hexagon squares. However, but if you could clearly see, there is more number vanhu vakawandira between the age of. Alright, so now we are now comparing age to the actual probability of giving birth through C-section. Okay, so C-section, cesarean section is in blue, and not in the Caesar, it's now in orange. Alright, so as you can see, according to this chart, according to this data set, women between the age of 24 and 26 had the most probability of delivering through C-section type of birth, and women between the age of 33 and 34 had the least probability of delivering through C-section, according to this data set. We don't know it was taken in America or in South Africa, we don't know, but according to this data set, these are the observations. So automatically, if you are a woman and aged between the age of 33 and 35, you can have a good confidence that you could deliver through a normal birth, according to these statistics. All right, so as you can see, we have a line that shows the relationship between delivering through normal birth and delivering through by a C-section, and also against age and the number of prior deliveries. All right, so we just need to click run so that we can run the next part of the source code. Now we are now comparing two values, number of prior deliveries and the possibility of a C-section birth. Alright, so as you can see, we have the people who have delivered through a C-section are the ones in orange, and number of people who are delivering a baby for the first time, they have a bit higher chance of delivering through C-section, because delivering through section is now in orange, so they have a high chance of delivering through C-section, and if a person is delivering for the fourth child, he has an extreme high chance of delivering through C-section, according to the data set. So there is a very minimum chance that a person delivering for the fourth baby could deliver through normal birth, according to the data set. That's what is important, according to the data set. All right, so here we are now comparing blood pressure against delivering through a C-section type of birth, according to this chart. All right, so now we are comparing blood pressure against a number of people who have delivered through C-section, right? So according to this data set, people with a normal blood pressure, we have more of them that deliver through normal birth, people with a normal blood pressure. However, people that deliver also through C-section with a normal blood pressure, they are also relatively high. All right, right. So this is these are just comparisons of what really might take place. So as you can see, people with a high blood pressure, most of them, they deliver through C-section. So these are just different type of information that we can collect from the data set. All right, so here people with a heart problem. So let us start with people with no heart problem. So we just need to run it first, and then see if it can give us a different chart. All right, now moving to the next, we have a heart issue with the possibility of giving birth through C-section. Right, so according to this data set, a large number of people who deliver through normal birth do not have a heart problem, and also a quite larger number of people who deliver through C-section actually do have a heart problem. This is what we derive from this data set. So moving onwards, we now need to present our our findings through a scatter plot diagram. Right, So we could just change the colors the way we like. We can make the orange the blue, the orange, the green, or whatever. We can make anything that we like. This is the flexibility of Python. You can do anything with it, absolutely anything. It's not rigid like doing these charts using another language, right? Even like JavaScript. It's not rigid like that. It's quite flexible, right? So these are the possibilities of delivering through C-section with your prior deliveries. How many times have you delivered before, and what is the possibility that you deliver through C-section as well? So previously, if you have premature prior deliveries, there is a very large possibility that you deliver through C-section. That's what we could derive from that chart. And also now we need to present the data or the findings through a scatter plot diagram. Alright, so it depends. The scatter plot is rarely used, but if you could use it, then it's up to you, right? Alright, it's quite confusing because we need to compare different variables from the dataset, different categories of the information from the dataset. For example, if the delivery time, that is, if the delivery time is normal, it's not premature and it's not late, and the blood pressure as well is normal, and the delivery number, that's it, from the 1 up to 4 babies, what is the possibility of delivering through normal birth, and what is the possibility of delivering through C-section? Alright, so that's shaded in dots. So the variables, we can change them the way we like. For example, the next chart, the delivery time is normal, but however the blood pressure now is no longer 0, it's now 1, and we just mix things up so that we could at least see how this distribution in C-section births against blood pressure, because blood pressure is the only variable that is changing here. And also on the next on the second line, you can see that delivery time is the one that is changing as well. So these are different ways we could present data. If you could explain it, and if it can be so useful to you, you can as well implement it and use it for your own system. Alright, so once again, thank you for watching. Thank you for watching and for supporting. Truly, I can see the incoming messages and the comments as well. Thank you for your feedback and thank you for your support. You are the ones that give us the energy and to keep forwarding the content and improving the content as well. Thank you all, thank you and everyone. We are working with people from different nationalities and countries. Thank you all for your trusting, and I believe it's a mutual transaction. You just give us the requirements of the system, we make it for you, we send you a video, and then you can approve. Then you can approve for us to go to the next stage, and then from there you can make the transaction. Then by making the transaction and already you have seen a working video of your system, then we send you your system, your source code, or even we can upload it for you online if that is what you like. Alright, so thank you all for your support.